When you take a deep breath outside, have you ever wondered what's really in that air? It may look like there isn't anything there, everything appears clear, but in reality, you have just inhaled several different gases and particles you cannot see. Let's talk about two components of the air you just inhaled, focusing how they affect our health and the environment. Let's do a little history here before we get too far into this. The Clean Air Act of 1970 requires the EPA to set acceptable standards regarding the emissions of 6 common air pollutants called criteria air pollutants. These pollutants can harm our health and the environment, and we'll be discussing fine particulate matter, also known as PM 2.5, and ground level ozone. When you have a moment, take the time to research what the other 4 criteria air pollutants are and how they affect our health and the environment. First, what is air? Nitrogen and oxygen make up 99% of Earth's air. The remaining 1% is a mixture of carbon dioxide, hydrogen, and other gases and metals. Most of these components occur naturally. Air also contains aerosols, tiny dust, sand, and pollen particles that mix with liquid. Air pollution happens when harmful substances are released into the air. Human-made pollutants, such as the emissions from power plants burning fossil fuels, smoke from wood-burning stoves, and car exhaust are the most obvious and visible examples of pollution sources. Wildfires, dust storms, and volcanic eruptions are sources of natural pollution. Let's discuss fine particulate matter and how it affects our health and the environment. The fine particulate matter, also known as PM 2.5, is defined as a mixture of fine particles and liquid droplets 2.5 microns in diameter or smaller. That's 30 times smaller than the thickness of a strand of hair. This slide illustrates just how small PM can be. There are other particles that are easier to see, like sand and dust. Fine PM poses a threat to our health because it travels farther and deeper into our lungs and can cause serious health problems. PM 2.5 also contributes to the haze we see in the air. When sunlight encounters tiny particles of pollution, some of the light is absorbed by these particles and some is scattered, which reduces the clarity and color of what we see. Remember the size of particles we've been discussing. If sunlight can be affected, that's a lot of stuff stuck together. Wildfires are a great example of naturally occurring air pollution. As we saw this summer, smoke containing particulate matter was caught in the jet stream and transported across the country. This movement of smoke made the air quality in affected areas reach harmful levels, even though these fires were hundreds of miles away. As you can see from the illustration and the darker areas, the smoke is traveling from the west coast across to the east coast. In 2019, Australia experienced some of the worst wildfires they've ever had. The aerosols and particulate matter from the burning vegetation was so thick and extended so far up into the atmosphere, it actually circled the globe. There was so much particulate matter emitted into the atmosphere, temperatures in the southern hemisphere were cooler than normal. This was due to the sunlight being reflected by all of this particulate matter in the air. We have seen how the wind or the jet stream can carry smoke hundreds to thousands of miles away from its source. Wind can also be a good thing as it can help disperse the pollution that's creating our haze or the smoke from the fire. The next pollutant we will talk about is ozone. There are 2 types of ozone, good and bad. The good, or stratospheric ozone, occurs naturally in the upper atmosphere where it protects Earth from harmful ultraviolet rays emitted by the sun. Bad ozone, or ozone at ground level, is a harmful air pollutant and is a main ingredient in smog. This ozone can have adverse effects on people with asthma and other breathing or health issues, especially during hot weather. This is why you occasionally see ozone alerts. High concentrations of ground-level ozone are not naturally occurring. They're the result of chemical reactions between nitrogen and volatile organic compounds. VOCs are things like gasoline and paint vapors, or ingredients in chemical solvents. These chemical reactions take place when pollutants from car exhaust, power plants, and refineries react in the presence of sunlight. Ozone can be transported long distances, just like the PM 2.5, which can affect areas further away from where the reactions occur. Ozone contributes to what we typically experience as smog or haze, most frequently seen in the summertime. That was a pretty brief and quick explanation of the two different types of ozone. For a more in-depth view, I'd like to turn you over to one of my colleagues. But before we go, if you'd like to stay informed about the air quality in our area, please go to the DEQ website and sign up for the Air Quality Alerts.
The reason I'm able to lay out here is because the ozone layer is blocking up to 97% of harmful UV rays. Without it, in just a few minutes, this could be me. My skin hurts. What happens when those same molecules are created down here with us? Automobiles, planes, and even your lawnmower at home. All generate pollutants that react with sunlight to create ozone, affecting our air, our lungs, and even our plants. Excuse me. That's why we monitor for ozone. Sorry. That's why we monitor for ozone with analyzers like these. We've got circuit boards that control the instrument, a pump that draws air in, and a photometer where the magic happens. This is the important part. Air from the outside comes into this tube. This UV lamp shines light back down the tube to the detector, where it calculates the amount of ozone using an equation called Beer's law. Not that Beer's law. That Beer's law. We calculate ozone by starting with the known amount of light. As we add more ozone into the tube, the more light is absorbed by the ozone, and the less light is detected, which gives us a number for how much ozone is in the air. So how can we prevent ozone? Simple things like keeping your engine tuned up, keeping your tires properly inflated, conserving energy in your home, and fun things like carpooling.
Today's experiment is making smog. What happens when particles from smoke and fog mix? You get smog. Smog makes the sky look gray and hazy, sometimes brown, and oftentimes the air does not smell very good. It can cause your eyes to burn and water, and it makes it difficult to breathe if you have asthma or other issues. The word smog originated in London, England in the early 1900s. A thick haze formed over the city when particles of soot from burning coal mixed with water vapor in the air, also known as fog. The two words smoke and fog were shortened to make smog. I have all my supplies out here already, and we'll go ahead and discuss those here in a minute. We're going to make smog today in a jar. It's really simple, very easy. We need a jar. This is a jelly jar, whatever you've got, just make sure it's clean. A pair of scissors, a piece of paper. We're going to cut a strip off of this to make our fuel or fire for our smog. You also need some foil to make a little lid to go on top of your jar. Did I mention matches? We need matches. The thing with the matches is this is where the most important ingredient comes in and the most important supply. An adult. You must have an adult to do this experiment with so that you stay safe. We also will need 2 to 3 ice cubes to go on top of your lid. The first thing we're going to do is we're going to make a lid for our jar out of our aluminum foil. So just go ahead and tear off a little piece. You just want enough to cover the top of your jar. It doesn't have to come down very far. Kind of want to get a tight seal. Also, you want to be sure that you have a well or an indentation in the middle of your foil. Right here. This is where your ice cubes will go to help with our smog. The ice cubes are used to cool the inside air in your jar because it's the colder atmosphere that traps heat close to the ground that helps create smog. So we want to put a little bit of water in our jar. You don't need a whole lot, maybe an inch, half an inch. Swirl it around really good so that you get the side, swirl it around really good so that you get the sides kind of damp, and then pour it out. Once you've poured it out, take your lid that we've made with your ice cubes and put that back on. That will allow the air to cool and help create our water vapor. Okay, while the air is cooling in our jar, kind of helping create our water vapor, I'm going to set that off to the side, and we're going to make our fuel for our smoke. You want to cut a piece of paper about 1/2 inch wide and 10 to 11 inches long. Okay, once that's done, you'll fold it in half. Doesn't have to be exact. And then start twisting. We're making our log or fuel to create our smoke to mix with our water vapor to make smog. Okay. Our air inside our jar should be cooled enough to create vapor. So we're going to carefully remove your lid. Be sure not to drop your ice cubes. If you do, that's okay. This is where the adult comes in. The adult is very, very important. They will light the match and set the fire. Once we kind of get our fuel going, we'll drop it in our jar and then quickly but carefully replace your lid. Okay? As you can see, the smoke is getting trapped underneath the cool air and mixing with the water on the side of the jar, our water vapor, and we're making smog. While our smog is forming, let's go ahead and talk a little bit about smog today. Smog is common in big cities, mainly because of the amount of traffic from our cars and trucks on the roads and the industries that surround the area. When sunlight heats up the exhaust fumes from cars or smoke that comes from factories and power plants, chemical reactions happen, creating smog. Okay, we've just created the conditions for smog. We added air pollution, our smoke, to a closed environment, which was the jar. We'll also consider that our city. The ice cubes on top mimicked the cooler atmosphere higher in the air, traps the heat and the smoke and the water vapor underneath, creating smog. Based on our discussion and the experiment, here are a few things to think about. 1, why did the jar need to be wet? 2, was it the smoke from the paper or the particulate matter in that smoke that helped create the smog? Why were the ice cubes needed and what was their purpose? Thank you for joining us today in making smog in a jar.